Okay, hello everyone in a new video. In this one we are going to start part 1 of chapter 5, which is the chapter of generators and receivers for grade 10 students. Then let me write the title of this chapter. Here we have chapter 5. Generators and receivers. And let me write here section number 1, which is the generators and receivers, in order to define or to explain what is meant by each of these two terms. And let me start by explaining what is meant by a generator. Then referring to this word or to this terminology, which is the generator, so it's coming from generate. So generating what? Generating electric energy. So generators are electric devices that transforms or transforms one form of energy into electric energy. So let me say generator is an electric device that transforms energy into electric energy. And here let me be very specific, although it is named to be generator, but we have used the terminology which is transform. So it is transforming one form of energy, is an electric device that transforms energy into electric energy. So here I didn't specify the form of energy that is being transformed into electric energy. The important thing is that energy is being transformed and not created. Okay, because we know that energy cannot be created, cannot be nor destroyed. It can be transformed from one form into the other. So here we are talking that any form of energy, when it is being transformed to the electric energy, then this is known as a generator. And now the receiver. So examples on generators. So battery is a good example. So in which battery transforms chemical energy into electric energy. Now receiver, the receiver is an electric device that transforms electric energy into any other form. And on this, let me give the following example, which is the lamp, motor, etc. Here we can also, in addition to the battery, we can give an example, which is the alternator of a bicycle or power stations, etc. Okay, or an AC voltage source, not necessarily DC. So these are in brief generators and receiver. Now if you consider a simple electric circuit, which is given by this, Now in this case, the battery is classified as a generator, the resistor and the lamps are classified as receivers. So the battery is the one which is delivering the energy. It's transforming chemical energy found in the cell into electric energy. The resistor and the lamp are receiving this electric energy and they are transforming it to another form. The resistor is transforming this energy into thermal energy. The lamp is transforming this energy into light energy and thermal as well. Okay. Now let me discuss the following sections. So let me start with section number 2 and let's go into details in the generators. So the generator. So previously we know that each battery, so say for example, suppose that here we have the voltage across the battery UPN is equal to 12 volts, and so previously also we have discussed the indications of the lamp. So if the lamp carries the following indication, 6 volt, we know what is meant by this indication. Now we need to discuss the indications on a battery that we didn't discuss till this moment. Now let me start by 2.1, indications on a generator. Given a generator G, carrying the following indications, that are given by G, say for example 12 ohms. So previously all the cases that we have discussed, the generator only carries one indication. Now in this case the generator carries two indications, 24 volts and 12 ohms, and now we want to answer the following question: what does each of the above indications represent? So let's start by 24 volts. So these are the indications of a generator and not for a receiver. So 24 volts represents the electromotive force which is the maximum voltage of the generator with no load. And as for 12 ohms, this is given by the internal resistance that causes the heating of the generator. Now it's a bit complicated to explain physically what is meant by 24 volts and 12 ohms. Now I will refer back to the meaning of these indications after I discuss Ohm's law for a generator. So now let me directly move to section 2.2, which is Ohm's law for a generator. So now let's suppose that we have a generator that carries the following indications: 24 volts and 12 ohms. And suppose this is the point P and this is the point N, and we are interested in applying, so because the generator now carries another indication which is ohms, so one can directly ask what is the relation between ohms and volts. So because ohms appear, then this thing is directly related to Ohm's law, so we can say according or apply Ohm's law to G. And now suppose this is delivers a current I in this direction. Now the direction of the current is important. Now in this case the direction of the current is from negative pole to the positive pole, like this. Because this is a generator, this is the one delivering the current. Then Ohm's law is given by U is equal to E minus IR. So here let me write it in the following way, that G is given by E and R. In this case E is the electromotive force, in this case is given by 24 volts, and R is the internal resistance, and it's given by 12 ohms in this case, in this example that you are considering. So this is Ohm's law for the generator. Now notice that here I didn't label the points. Now before I label the points, let me discuss what does each quantity represent and what's the type of this equation. Then let me say here where U is the voltage across the generator, and V for volts, it's SI unit. E is the electromotive force, and it is also expressed in V in volts. I is the current traversing the generator, and it's given by A for amperes. And finally R is the internal resistance of the generator. And it's given by omega for ohms. So here this generator is being characterized by the following quantities: E, the electromotive force, and R, the internal resistance. So the voltage across the generator is given by E minus IR. So why here we have a minus sign between this term and this term, and more importantly, what does each term represent? So because this generator has an internal resistance, part of its energy is being dissipated as heat energy due to Ohm's law, which is given by IR. Okay, for this reason here we have a minus sign, because part of the voltage of the electromotive force of the battery is being dissipated as an internal resistance in the following and the resistance inside the generator. Okay, now U is the voltage across the generator. Here I didn't label the voltage U to be UPN or UNP. Now because this is a generator and it's the one responsible for delivering the current, in this particular case the labeling of the points will be UPN moving in the opposite direction of the current, not from N to B but B to N, because we are used to this fact. Whenever we are measuring the voltage of a battery, then the voltage of the battery will be measured from the positive pole to the negative pole. Okay, so this is extremely important whenever we are discussing the voltage across the generator and we want to apply Ohm's law. We need to move in the opposite direction of the current, or from the positive pole to the negative pole. Okay, so I will be the current traversing the circuit and R is the internal resistance of the generator. Okay, so let me give an example on this. Now suppose we have a generator G carrying the following indications: 24 volts and 12 ohms, and we know that whenever it's being connected to a closed circuit, for example, then it will deliver a current given by 1 amperes. And this is the point P and this is the point N. Now previously we used to write that UPN is equal to 24 volts, but this is not the case because now we have an additional term due to this internal resistance. So we cannot say that UPN is equal to 24 volts. This is wrong. We need to say apply Ohm's law to the generator G, and the voltage U is given by E minus IR. But now we need to place here the points. It will be either UPN or UNP depending on the direction of the current. Since this is classified as a generator, then we will move from the positive pole to the negative pole. So this is P to N. So now in this case, this is equal to 24 minus 12 multiplied by 1. So this is equal to 12 because everything is expressed in the SI. So this is 24 minus 12, which is equal to 12. Since everything is expressed in the SI, so the value of UPN will be in the SI, which is volts. So UPN is equal to 12 volts. Now in this case, the applied voltage across the battery is given by UPN is equal to 12 volts. And here one should distinguish between the voltage supplied by the battery and the electromotive force. And let's write the following important remark. So 24 volts is the electromotive force and not the voltage supplied by the battery. So in this case, UPN is equal to 24 volts is completely wrong. The supplied voltage which is given by UPN is determined using Ohm's law for a generator, and it's given by UPN, or simply U because we don't know the direction of the traverse current, which is given by E minus IR. So it's a good habit whenever we don't know the direction of the current to leave it U as it is without labeling the points, which is given by E minus IR. Whenever we have an electric circuit, we can refer to the direction of the current, and whenever it's a generator, we can know how to label the points. Okay, depending on the direction of the current, for sure. So this is it for the generator. Now let me move to the other section, which is the receiver. So the previous section here, 2.1, was given by indications on a generator. Here, let me say indications on a receiver. And let me say, given a receiver, I will not label this receiver to be R, but rather AM, because the motor, AM stands for motor, is a good example of a receiver. Let me use the same values, or let me say, for example, 12 volts and 4 ohms. So let me say, given a receiver AM carrying the following indications. What does the indications 12 volts and 4 ohms represent? So another example of the receiver is a lamp L. So previously, if this term was not present, we used to justify to say or to state that the 12 volt is the rated voltage of the lamp L under which it functions normally. Now here the case is completely different. Now this receiver, which is AM, carried two indications, 12 volts and 4 ohms. So we cannot say here that 12 volts represent the rated voltage of the motor AM. Now 12 volts have another important meaning, and let me write here 12 volts is the back electromotive force which is the minimum voltage required or needed by the receiver to operate. So in order for this motor to start to operate, 12 volt is the amount of voltage needed for the motor to start to operate, not to function normally. Okay. Now what about 4 ohms? 4 ohms is simply the same for the generator, so it is the internal resistance that causes the heating of the receiver. Okay, so these are the meanings of these indications. Now, in order to illustrate more, we need to discuss Ohm's law, then section 3.3 and 3.2. Ohm's law for a receiver. And now suppose here that we have a receiver and this receiver may be a lamp, maybe a motor, we don't know. Now this receiver, suppose it's the receiver X or M carrying the or the receiver D carrying the following indications that are given by 12 volts, 4 ohms. Since the term ohms appear on this generator, then for sure it is related to Ohm's law. So apply Ohm's law to D. Suppose in this case the current is being traversed like this, and the value of this current is given by 0.5 amperes. So what's the relation between the applied voltage across this D, the back electromotive force, and the internal resistance and the current? So according to Ohm's law, they are related to each other by the following formula: U is equal to E plus IR. So instead, if you want to compare, so this is for a receiver, and for the generator, simply this plus sign will be a minus sign, then it will be given by E minus IR. So this is for a generator, because it is generating electricity, so the electricity or the power delivered by generator is being dissipated. So for this reason we have the minus sign. For a receiver, because the power is being, or the voltage is being gained, then here we have a plus sign. And notice that here I didn't label any points. So let me say that this is the point A and this is the point B. And in order for this voltage to be positive, then we need to move in the flow of the current. So in this case, this is UAB. Exactly similar to the case of the resistor. So actually the resistor is a receiver, but with no back electromotive force. Now let me say where E, so UAB, and here let me write the points also. So in this case this is UPN, or U, it's the same. Let me here place it to be U. U is the applied voltage, across the receiver, and it's given by V, which stands for volts. Now as for E is the back electromotive force. So what does E represent? Now in order for this component to function normally, at least we must supply it by an applied voltage given by 12 volts. Okay, so at least to start to operate is the back electromotive force, and V for volts. What does R represent? R is the internal resistance of the receiver. And omega for ohms. And finally I is the current traversing the receiver. And it's given by A for amperes. Okay, now let me give an example on this one. So let me consider the following example. So suppose we have the following electric component, and we know that this electric component is being classified as a receiver. and we are interested in determining the voltage AB. It's completely wrong here to write that the voltage AB is given by 12 volts because this has an internal resistance. Then we can say apply Ohm's law to D. And in this case, Ohm's law is given by U because, so E, and here we have IR. Because this is classified as a receiver, then here we have a plus sign, and we need to move in the direction of the current, so from A to B. Now the value of E in this case is given by 12, and the value of the current traversing this receiver is given by 0.5, and the value of the resistance is given by 4. Plugging this expression on the calculator, then we have 14. Since all of these are expressed in the SI, so the value of V will be expressed in the SI, which is volts. Then the applied voltage across this receiver is given by 14 volts. 12 volts are needed in order for the receiver to start to operate, and 12 volts are responsible for the dissipation of heat and across the internal resistance. Now I'm not going into details in all of this stuff. What's important for me now just to apply to understand the meaning of these indications, that they are different than the applied voltage that we have discussed later. Later on during the chapter, I will explain explicitly what is meant by heat dissipated, and we will review back what is meant by Joule's effect. So here now in this case, the applied voltage here is given by UAB is equal to 14 volts. Which is different than the back electromotive force across the receiver. So notice that always across a receiver, the applied voltage is greater than the back electromotive force, and in the case of the generator, the electromotive force is less than the supplied voltage is less than the electromotive force. Okay. And here let me write a similar note in case of a receiver. So let me say here the following note. "12 volts is the electromotive force, back electromotive force, and not the applied voltage across the receiver." And now as for idea number 2, the applied voltage can be determined using Ohm's law, which is given by U is equal to E plus IR. Okay. Now, as a direct application on what we have explained so far, let me solve the following exercises. Given a generator G 24 volts and 1 ohms, and number 1 they are asking me what does the indications 24 volts and 1 ohms correspond to. So this is straightforward. Let me start by the 24 volts is the electromotive force, which is the maximum voltage supplied so let me say the maximum voltage, let me use the same, which is the maximum voltage of the generator of a G with no load. So I'm trying to use the same definition that I have referred to in section 2. So it is the electromotive force, which is the maximum voltage of the generator with no load. Now as for 1 ohms, what does 1 ohms represent? Since it carries the unit ohms corresponding for the resistance, which resistance we are talking about? It's the resistance found in the generator, which is said to be the internal resistance. That causes the heating of the generator. Now in number 2, they are asking me calculate the voltage across the terminals of the generator if it sends a current of intensity 1 amperes. So we know the value of the current traversing the generator, we know its electromotive force, and we know the resistance. Then the current can be determined using Ohm's law, so apply Ohm's law to G. Then Ohm's law is given by UG is equal to EIR. Since this is classified as a generator as mentioned here, then it will carry a minus sign. Here no need to distinguish between 2 points because we are not considering an electric circuit. And we are interested in calculating the voltage. So this is the quantity that we are interested in calculating, which is equal to the value of E, which is the back electromotive force, which is given by 24, minus the value of the traverse current, which is given by 1, multiplied by the internal resistance, which is also given by 1. So this is equal to 24 minus 1, which is equal to 23. Since everything is expressed in the SI, so the value of UG will be in the SI, which is volts. So UG is equal to 23 volts. And as a verification, because this is classified as a generator, so notice that always the supplied voltage is less than the electromotive force, because what does the electromotive represent? It is the maximum, which is the maximum voltage here. Maximum voltage. So because it is the maximum voltage, always the value of the supplied voltage will be less than the maximum voltage. So this is it for number 2. Now in number 3, they are telling us, so all of these parts 2 and 3 are independent. Okay. So now we can forget about part 2. They are telling us in number 3, calculate the intensity of the current sent by the generator if the voltage across its terminals is given by 20 volts. So this voltage represents the 20 voltage. As a verification, it's less than the electromotive force. Then the value of the current can be determined also using Ohm's law. So apply Ohm's law to G. And in this case, Ohm's law is given by UG is equal to E minus IR. And we are interested in determining the value of I. So the value of UG, which is the voltage across its terminals, is given by 20, which is equal to the back electromotive force, the electromotive force, which is given by 24, minus I multiplied by the internal resistance, which is given by 1. So what's the type of this equation? This is a linear equation and one unknown. The unknown is I. So how do we solve for I? We arrange I on one side and all the others on the other side. So dragging I to the left hand side and dragging 20 to the left hand side. So here we can say that 20 is equal to 24 minus I, because I multiplied by 1 is I. Now dragging I to the left hand side and dragging 20 to the left hand side, the equation is being reduced to the following form: 24 minus 20, which is equal to 4. Since everything is expressed in the SI, so the value of I will be in the SI, which is amperes. Then in this case, according to Ohm's law, the value of the current traversing this generator is given by 4 ohms. So that's it for me in this video, guys. In the next part we will solve more exercises on this chapter and complete the explanation.